Alright class, welcome back. Today we're going to talk about multiplying polynomials. For our current book, this is section 5.4, but the topic is multiplying polynomials. So we just had a big discussion in 5.3 about all of the lingo for polynomials. So we learned things like monomial, binomial, trinomial, etc. That a monomial has a single term, binomial has two terms, terms are separated by addition and subtraction, etc. So if I want to talk about multiplying polynomials, the first thing that I might see is multiplying, say, like a 3x squared by a negative 6x to the fifth. Well, this term here is a monomial, and this term here is a monomial. That means that it's all related through multiplication. Or in other words, this says 3 times x, and this says times a negative 6 times x, times x, times x, times x, times x. Well, again, this is a constant stream of multiplication. There's no addition or subtraction here. This sign right here is not addition or subtraction. It just says, hey, that's the negative version. So I'm going to take 3 times negative 6 and get negative 18. And then I'm going to count 1, 2, 3, 4, 5, 6, 7. I have 7 x's related through multiplication. Of course, we could use our rules of exponents and say 2 plus 5 is 7. But a monomial, okay, a monomial times a monomial, mono, okay, so monomial times a monomial is just a constant stream of multiplication. So you're literally just multiplying together what you were given. Okay, you might have two things, you might have three things. Maybe you have a negative 5ab squared times 2a squared b cubed times a 4a to the fourth b, something like this. Well, this, again, is just a constant stream of multiplication. There's no addition and subtraction in here, so I'm just going to say, well, when I multiply all this together, what do I get? Well, starting with my constants, 5 times 2 is 10, times 4 is 40. It's going to be a negative 40 because there's only a single negative. Okay, and then I've got 1a, 2, 3, 4, 5, 6, 7 a's related through multiplication here. Or in other words, 1 plus 2 plus 4. Okay, and with the b's, we have 2 plus 3 is 5. Plus 1, remember if there's not 1, there's not a exponent, that the exponent is 1. So we're going to get 2 plus 3 is 5 plus 1 is 6, so we have b to the sixth. Okay, so this is another example of monomials times monomials. Sometimes we won't just have monomials, we might have a monomial times a binomial or a trinomial or any kind of polynomial. So we might have a monomial multiplied by another polynomial, whether that's 2, 3, 4 terms, doesn't matter. So if I had, let's say 2y, that could be multiplied by x squared plus z plus 7. Okay, and this is a monomial right here being multiplied by a polynomial, which happens to be a trinomial because there are 3 separate terms. Okay, so what we're going to do here is we are going to use the distributive property. The distributive property says that if you have one thing and you want to multiply it following the order of operations, I should be adding these together inside of here, right? Parentheses says do me first, but x and z and 7 are not like terms, so I can't add them together. So the only thing I can do here is multiply. So we would get a times b plus a times c. So here, when I multiply, I get a 2x squared y plus a 2yz plus a 14y. Now I always get someone that asks me, like, does the order of the variable matter? Well, we know that the order of the multiplication doesn't matter, so x times z is the same thing, or sorry, x times y is the same thing as y times x. Because if x was 2 and y was 3, 2 times 3 is 6 and 3 times 2 is 6. So the order doesn't matter, but typical format of these answers will always be actually in alphabetical order. So if you have x and y, x comes before y. If you have y and z, y comes before z. So we would write them in alphabetical order if we have more than one variable. Okay, so this is multiplying a polynomial, whether I have two or more terms, a single term by two or more terms. But what if I had two terms that I wanted to multiply together? So I want to multiply together x plus 3 and x minus 7. So I have two terms here. So if I want to multiply a binomial times a binomial, then what do I do? Well, to do this, we're going to use a method called FOIL. Let me write this over here. So the method we're using is FOIL. But really, remember, we're just distributing like this. When we distribute, you say, hey, both of these terms, x and 3, have to be multiplied by both of these terms, x and 7. Remember that the sign separates it. So if I were to distribute this, I'd say x needs to be multiplied by x, and it also needs to be multiplied by -7. I need to distribute it into both, just like we distributed here. Okay, and I also need to multiply this 3 by both of these terms. So now every one of these terms have been multiplied by the other. Well, if you look at what we just did, FOILing stands for firsts, outers, inners, and lasts. FOILing is just a way to keep track of what you've done. So we took the first term in the first parenthesis and multiplied it by the first term in the second parenthesis, right? That's just this distribution here, x times x. So that gives us x squared. Then we did the outers. Well, I just did x times the 7, which you would naturally do anyways. We're going to say I did the outside one and the outside one, okay? Well, -7 times x is a -7x. Well, now I'm going to move to the 3 because I've already multiplied this x by both of these. So now I'm going to move to the 3. I'm going to multiply the 3 by the x. Well, that would be the ones that are the two terms that are on the inside. Okay, so that's the inners. That'll give me a 3x here. And then I'm going to do the last, the 3 multiplied by the -7. So the last term in the first binomial and the last term in the second binomial. That'll give me a -21. So this method of FOILing just means first, outers, inners, last, and it's just a way to keep track of what you've done. Okay. So something we need to notice here, and this is often where mistakes are made, is that we just did multiply, multiply, multiply. But remember, now we need to check and see if we can add like terms. Well, the 7x and the 3x are like terms. So we need to combine them, and when we combine like terms, we combine their coefficients, not their exponents. So if I said I had 3 apples, x is apples, and I took away 7 apples, then I would have -4 apples. That wouldn't change. This x is still x. It doesn't become x squared. Okay, remember I combined the coefficient. -7 plus 3 is -4, but it's still x. I'm still talking about x. So the mistake that people will make here is they'll say, oh, that's x squared minus a 4x squared minus 21, and then they'll be like, oh my gosh, those can go together too. And then you end up with some funky thing like this. This is totally wrong, because when we combine coefficients, when we combine like terms, we combine their coefficients, not their exponents. Why aren't we combining their exponents? Because they're not related through multiplication. -7x times 3x is different than -7x plus 3x. This would give me a -21, and an x times an x, I would say x squared. Totally different than adding them. Okay, so this is a binomial times a binomial, one way to do that. I want to show another way that I don't ever use, but some people find it helpful, and I don't really recommend it either, but just to give you options here. Some people have seen the box method. So it looks like this, and then you just line up the terms. So you'd put on the top the first binomial, an x and a +3, and on the bottom you'd put the second down this line here in the column. So, and you could list them either way, because in multiplication the order doesn't matter. So I could have listed the x plus 3 here and the x minus 7 here. But in this box I'm going to put the two that are touching it. So there's an x and an x. Well, x times x is x squared. Okay, in this box I'm going to put the 3 and the x. And in this box I'm going to put the 7, because it's in this row and column, okay, and the x. And here I'm going to put the 7 and the 3. And again, all of this is related through multiplication. So I'm going to have a negative 21. But you'll notice here that these diagonals will sum. So you can get that x squared minus a 4x minus 21. Don't know if this is helpful, but it's one other way to see what's actually happening here. So what I want to do now is talk about a couple of special products that when you multiply them together, something unique happens when we multiply these binomials together. Okay, so we're still talking about binomials times binomials, but what happens, okay, so I once had, this is kind of a funny story. I once had a student who took my class. Oh, he hated math, but he, when he got in my class, he really decided he wanted to try, and the first go around he failed it, and he took it again, and he bought me a book called F in Exams. F in Exams. I don't know if you've ever heard of it, but it's pretty funny. Anyway, he bought me this book the first time he failed the class, and the first time he took the class, and it's just full of like all these hilarious things. Like it'll be like, you know, x times x plus 2 is equal to 7, and the instructions will say find x, and someone will go like this. They'll say here it is, right? And it's just all of these like hilarious things that students do on their exams. Well, this one actually applies to the lesson today. So this one would say expand. Okay, so it would say expand this, and then it would have x plus 2 squared. You're supposed to expand it. Well, the student in this F in Exams went like this. Okay, although this is one way to expand this expression, this is not what expanding this means. Okay, so if I have two terms and they're squared, I mean, that is pretty funny, but if I have two terms and I want to square them, so I have x plus 2, and I want to square it. Well, remember that what this means that is the x plus 2 is my base, and I have it 2 times. It literally means that I have x plus 2 times x plus 2. Now, everyone says, well, wait a minute, why can't I just dump this exponent in? I mean, that's what we did before. Isn't this like x squared plus 4? I mean, that seems like that should work. Well, before, it wasn't separated by addition and subtraction. Before, when we were learning the rules of exponents, I might have had something like 3y squared, and I wanted to cube this. Well, again, remember that this expands to 3y squared times 3y squared, which means everything in here is related 3 times. Everything in here is the base, and it's related 3 times. But again, this is all a constant stream of multiplication. Notice there's no addition or subtraction in here. So that's great. I can't just dump this in here and say, oh yeah, that's 3 cubed, and then 2 times 3, that's a y to the 6th, and then simplify 3 cubed. Okay, 3 times 3 is 9, times 3 is 27, and get this term. But I can't do that here because everything inside of here is being multiplied together, which means I have 2 terms times 2 terms. I can't just dump it in. Now, maybe we would get this. Let's see what we do get. So when I FOIL this, I get x squared plus a 2x squared plus another 2x squared, or sorry, plus a 2x plus another 2x, excuse me, plus 4. And you'll notice right here that these middle terms, okay, these middle terms sum together, but they're also the same middle term. So in other words, there's 2 of them. There's 2 of these same terms. Okay, so but they sum together to be a 4x plus 4. Okay, let's do another one of these. Let's say I want to know what a 4x minus 9y squared is. Well, that means that I'm going to expand it, okay, because everything inside of this parentheses is happening twice. So I need to multiply first times the first. 4 times 4 is 16. X times x is x squared. 4 times 9 is a negative 36. And I have an x times a y. So I'm going to write that xy. I have the same thing here. Negative 9 times 4 is a negative 36. Y times x. Remember that when we're writing y times x, we're just going to write it as xy because the order doesn't matter. I can switch them around so that the format is always the same. Okay, and then negative 9 times negative 9 is a positive 81, and that's going to be y squared. Sorry, that's really close there. Y squared. Okay, so then I can sum these together. Again, notice that there are two of these terms right here that are exactly the same. So I get this 16 x squared minus a 72 xy plus 81 y squared. Okay, and that's the end result here. This one and this one. Now let's examine these for just a second and say, well, is there a pattern, or is there a difference, or is there some way to maybe think about this differently than just FOILing? Well, you'll notice that this first term here is the first term squared. It's x squared. And the last term is this last 2 times 2. It's 2 squared. Where did this middle term come from? Well, it's what's called the cross product. So 2 times x is 2x, and double that is 4. So I have 4x. Okay, so when you try to dump this in here, what you end up missing here is the cross product. 2 times x is 2x. Double that is 4x. That's where this came from. Okay, so how would I find the cross product here without expanding and doing all of this work? Well, I would just say that negative 9 times 4 is a negative 36. X times y is xy. And then I would double this, or basically times this by 2. Well, 2 times negative 36 is a negative 72, and I still have xy. So this is my cross product that you can see, again, is the middle term here. The first is the first term squared. The last is the last term squared. The only difference between this binomial squared and this binomial squared was the sign. Okay, this sign had a plus, and this sign had a minus. So let's see the end result, how that affected it. Well, the end result here, in this first one, was positive. And the end result here is also positive. That's because if you times a positive, the result will be a positive. Okay, positive 2 times a positive 2 was this positive 4. Okay, but here this was negative. Where'd the negative go? Well, a negative times a negative is also a positive. So this last sign will always be positive. So where does this sign come into play? Well, you can see here that the middle term will match whatever, oops, wrong line, will match whatever this sign is here. Okay, and the reason why I'm pointing this out is because we're going to start factoring. And when we factor, this is going to be important. So a binomial squared gives you a perfect square trinomial. So let me say that one more time. Binomial squared a binomial squared is going to give you a perfect square trinomial. That is the name. When I square this binomial, that's the name of this end product here that I get. Perfect square trinomial. It's a perfect square trinomial. I ran out of room there. Because the first term is squared. The last term is squared. Okay, so that's why it's called, and there's a middle term, so it's a trinomial. So a binomial squared will always give you this perfect square trinomial. So let's look at the generic formula of this. Again, this is going to come up in the next several chapters and throughout your math career from here on out. So you definitely want to make sure that you understand this concept. I keep shifting the... Okay. So if you have a a plus b, and this is whatever the first term is and whatever the second term is. Okay, and you're going to square this. Then what you're going to get is the first term squared and the last term squared. And then as you saw, every time we had two of the middle terms. Well, a times b is just going to be ab. Okay, but the last term is always going to be positive, because a positive times a positive is positive and a negative times a negative is positive. But this middle term right here, I'm not just going to have one of them, I'm going to have two of them. And the sign that goes right here is going to match the sign. Okay, so this is the general or the generic form of a binomial squared. So that's if I have a positive here, but what if I have a negative? Well, let's say this one more time. I'm going to get the first term squared, and I'm going to get the last term squared. This b will be squared, and it's going to be a positive because a negative times a negative is a positive. I'm going to get both of these middle terms times each other, but I'll get two of them. Remember when we multiplied it out. Okay, but this sign right here is going to be negative. Okay, so this is our perfect square trinomial. Again, these signs right here match. They always will. So this is a binomial squared. This is our perfect square trinomial. You're going to want to remember this. Got two more concepts here that I want to go over. This next one, I'm going to give you the generic formula first and then show you what happens and why it happens. Okay, so this one is going to be called a difference of two squares, or the product is the difference of two squares. What happens when you multiply a binomial together times that same binomial but with a different sign is you get a difference of squares. Okay, so this term right here and this term right here are called conjugates of one another. They're conjugates. This word and this concept is going to haunt you. It's going to come back. Conjugates are the same two terms with opposite signs. So if I said, oh, I have a 2x minus 7, what would its conjugate be? Well, the same two terms as 2x and a 7, but with an opposite sign. Okay, if I had y squared minus 5, then its conjugate would be y squared plus 5. Same two terms, just opposite signs. Okay, so those are conjugates. So if you have conjugates and you multiply them together, you end up with a difference of squares. So this right here is called a difference. Difference means subtract, right? Mathematics people are not very creative. This is called a difference of squares. That literally means exactly what it is. You're like, oh my gosh, that's a perfect square. Oh my gosh, that's a perfect square. And it's a difference of the squares. Holy cow. So creative. Can't even handle it. All right. So, well, what does this look like for real? So if I had, let's go back to, I don't know, let's say 5m plus 9, and I want to multiply 5m minus 9. Okay, so I'm going to FOIL these. These are conjugates. Note that. They're the same two terms with opposite signs. But when I multiply, I'm going to get 25m squared, my firsts. My outers, I'm going to get a minus 45m. My inners, I'm going to get a plus 45m. And the outers, I'm going to get a minus 81. Cool. Okay, so you'll notice here, oh, I didn't write my m. Okay, so you'll notice here that these are like terms, okay? And when you sum them together, they sum to 0. They sum to 0. This is an important fact to remember. That's how you end up with just two terms when you multiplied these together. Okay, so the end result here, if I were to multiply 5m plus 9 times 5m minus 9, is a 25m squared minus 81. Okay, this is a difference of two squares. Okay, so that is the concept of the difference of squares. All three of these right here are called special products. They're called special products because something happens that's unique when we multiply them together. Remember, product means multiply. So if we multiply binomial together with a positive sign, I end up with a perfect square trinomial. If I multiply a binomial together with a negative sign, or by itself, a binomial squared, I get a perfect square trinomial. But the difference is that they have matching signs to whatever the binomial was. Where here, if I use conjugates and I multiply them together, I get a difference of squares. Okay, so these are special products. We're going to talk a ton more about these as the semester goes on. Definitely worth noting these. And last thing I want to talk about is how to multiply something bigger than a binomial. There are lots of different ways to do this. Okay, but something bigger than a binomial. If I had y minus 1, and I want to multiply that by y cubed plus 4y minus 11, let's see, 4y squared minus 11y plus 6. Okay, now if I want to multiply these all together, I'm just going to have to distribute. So I can do it just like it's written. So this is written horizontally. Okay, and I can just say, okay, well this y right here needs to be multiplied by every one of these. 1, 2, 3, 4. Great, I can totally do that. So y times y cubed is going to give me y to the fourth. Y times 4y squared is going to give me a 4y cubed. Y times a negative 11y is going to give me a negative 11y squared. And y times a positive 6 is going to give me a plus 6y. So I've multiplied the first term by all four of those other terms. Now I'm going to multiply the second term. So again, I'm just distributing. When we distribute this sign with it. Okay, we distribute the sign with it. So a negative 1 times this y cubed is a negative y cubed. And a negative 1 times this 4y squared is a negative 4y squared. Negative 1 times the negative 11y is a positive 11y, and a negative 1 times 6 is a negative 6. Now I have all these terms here, and what I have to do is look through them and say, oh my goodness, are some of them like terms? And if they are, I need to combine them. So the like terms here, y to the fourth, there is no other y to the fourth. So it's just going to be y to the fourth. Okay. I've got a cubed here, so this term and its sign, and a cubed here. Okay, so those are like terms. So I'm going to put those together. A 4y cubed minus a y cubed is going to give me a 3y cubed. There's not another cubed, so we're good. I'm going to say that I've got a squared here and a squared here. So I've got a negative 11y squared and a negative 4y squared. Well, negative 11 and negative 4 are going to give me a negative 15. And that's going to be a y squared. Okay, I have a negative 6y and an 11y. So I'm going to combine those because they're like terms, and a 6 plus 11 is going to give me a 17y. And then this negative 6 doesn't have another constant to combine with. So this is the product of this binomial times this polynomial of 4 terms. Okay, so that's one way to do it, is just distribute it. But what if I started to say, well, let's do a trinomial times a trinomial, or something bigger than that? Good grief. Okay, so it might get really kind of hairy keeping track of all of the different stuff. So the way that I recommend doing this is that if you have anything bigger, if you're not distributing and you're not foiling, so if you have any kind of 2 or 3 terms, okay, 2 or 3 terms, and you're multiplying that by 3 or more terms, what I would recommend is doing vertical multiplication. So what we did here was horizontal. Vertical multiplication is actually what you've done your whole life. Maybe. Guess that's kind of a funny assumption. Okay, So it's supposed to be multiplication, but I ran out of room. So vertical multiplication. So if I said, let's take the number 419, and I wanted to multiply it by 275. The way that I do that is not by keeping them horizontal like this. I'm going to put one under the other, line them up in the ones column, tens column, hundreds column, and then I'm going to multiply. I'm going to start with the 5, multiply it by the 9, and say, oh, that's 45, carry the 4. 5 times 1 is 5, plus that 4 is 9. 5 times 4 is 20. Okay, so I get this 2095 when I multiply the 5. And then I'm going to move over to the 7, and I'm going to put a 0 right here because I'm no longer in the ones column. I'm now in the tens column, and I'm going to say 7 times 9 is 63, and so on. Okay, just like I would do this vertical multiplication, if I had a polynomial that had, say, the same coefficients here. So it would have 4x squared plus x minus 9, and I wanted to multiply that by 2x squared minus a 7x plus 5. Okay, so this is like 419 times 275, but just with polynomials, 3-term polynomials. What I'm going to do is I'm going to line these up. Okay, and then I'm going to do the multiplication vertically, just like we did right here. I'm going to say 5 times 9 is a negative 45, but it's even easier because I don't have to carry ever. This is my constant column, and I line them up. This is my x column, and this is my x squared column, and so on. If I had other ones, they would keep going. So now I'm going to take the 5 and multiply it by everything. Well, 5 times negative 9 is 45. 5 times x is 5x. 5 times 4x squared is a positive 20x squared. I always write the sign, so when we add them together, we can do that easily. Now I'm going to move over to this negative 7x. Well, because I'm multiplying a negative 7 times a negative 9, and I get 63, I get a positive 63. I'm putting it here, though, because it's a positive 63x, and everything that has x goes in this column. There's not going to be a constant here because I don't have anything that I'm multiplying together as a constant. Here I'm going to get a negative 7x times x is going to give me a negative 7x squared. Okay, and a negative 7 times 4 is going to give me a negative 28x cubed. And again, I'm just going to keep moving over. So x column, x squared, x cubed. Now I'm going to go to my x squared right here. 2 times a negative 9 is going to give me a negative 18, but it's still got that x squared, so I'm putting it in the x squared column. 2x squared times x is going to give me 2x cubed. Okay, and then 2x squared times 4x squared is going to give me an 8x to the 4th. So just make a new column. Now, the thing that's nice about vertical multiplication is all the like terms are lined up. So I know I'm just going to bring down this negative 45. I'm going to combine these together. 63 plus 5 is a 68x. 20 minus 7 is 13. Minus 18 is a negative 5. So we get a negative 5x squared. And negative 28 plus 2 is a negative 26. X cubed, and then I'm just going to bring down this 8x to the 4th. So this is vertical multiplication, and again, I recommend doing this anytime you have 2 or 3 terms times 3 or more terms. So this is the end of our multiplying polynomials lesson, and we will see you in class.